First, we have to know what is echelon form. Row recursive is row echelon form. All non-zero rows are above, any rows are all zero, right? We have non-zero, yeah, or zero. And each leading entry of a row is in a column to the right of the leading entry of the row above it. All entry in a column below leading entry are zero. So looks like this. So it looks like a triangle. Not exactly triangle. There is something like this one. If there is a rank of this matrix, in this case, rank of this matrix is only 2. We have a 4 row, but only 2 rows are dependent. Other rows are dependent on the others. So, yeah, so it is echelon form. And the reduced echelon form is the leading entry in each non-zero row is 1. And each leading one is the only non-zero entry in the column. Okay? So leading entry in a row is 1. And then when you have 1, this is the only non-zero element in a column. This is important. Yeah. So interesting theorem means that when you have a matrix, then only one reduced echelon form. There is not multiple reduced echelon form. You can find only one reduced echelon form per matrix. And the important term is that, so for example, yeah, yeah, I think this is today's problem, right? So this is today's problem. If you write this one in terms of matrix, it looks like this one, right? So it is it always, yeah, 맞나? 오늘 낸 문제 맞나? Yeah. So I think this is the very easy problem because once you write down this one in terms of matrix, it is in fact already row reduced form. So there is nothing to solve, right? So first one is very trivial. You can only write down this one into matrix, then it is done. You know, I'm a generous professor, so I wanted to make your life easy. So, right? The solution is just matrix, done. Now second is you want to solve this problem, then you can move it around. Basically, you can regard x4. I want you to solve this one in terms of x1, x2, x3. And then you can regard x4 as x2. In this case, actually, x2 and x4 is a free parameter. Slightly different. Yeah. So free parameter, and you can basically solve it. Yeah. The first one is easy, in that sense, right? Not so difficult. And about second one is also easy. Yeah, you can just solve it. Yeah. And the third one is the yeah. Can I see the student solution? Yeah. 잠깐만 주세요. Okay. 누가 잘했나 한번. Yeah. By the way, next time please don't use this one. Use A4 when you're handing out the please, because you know, maybe I may lose this one, right? If it is too small. Anyway. Yeah. Yeah. 현시 학생도 큰 종이를 사용하기 바랍니다. 어려웠나? 이게? Was it difficult? We have right solution over here. 노영철. 노영철 어디 있어? 노영철. 손 들어봐요. Come over here and show up your capability, please. 예, 나와서 풀어봐요. 3번. 로그하면서 미분하는 거. 4번도 거의 맞게 풀었는데 4번까지 풀려면 풀고 일단 3번 해보세요. please explain this third solution for third problem. This one. You have to speak. You have to explain. Yeah, but you have to do your best. You just spoke English. That's enough. Right? In mathematics, convenience in mathematics, English is not so difficult. You can just log a b x. That's all, right? So anyway, do your best to explain while you are writing down. 안 되지. 외국인한테 안 되지. Anyway, please complete your solution first. 먼저 풀어봐요, 일단. 네, 먼저 끝까지 풀고. Okay. 들어가요. Anyway, I think this is the answer. This is right because he is basically using chain rule, right? This is chain rule. So f g x, f prime g prime, right? And here, f is log function, g is a plus b. So he regarded this as y. So it is basically g function. So first part is simply a plus b, 1 over a plus bx, right? 1 over y. Now you have to add this one, second part, and then u derivative a plus bx with respect to x then equal b. So we have this one. This is solution, right? So it is y. So 1 over y. So yeah, it is chain rule, right? Y and y prime. So yeah. 질문 있어요? Any question? Yeah. So again, yeah. This is the So, it is like f x is like log gx, right? Something like this one. Here gx is, of course, a plus bx, right? So f prime is now, use the chain rule. First, you can regard this one as a big variable. So if you take derivative of log, we know this becomes like this one. It is the first part. And then chain rule, second part, g prime x. And then you can put this one over here, and g prime is simply b, right? This is simply b. So we are done. I put my differentiation of log x is 1 over x. I proved it. Yeah. We just use this one that log x prime is 1 over x. We studied it last class. Okay. And the third one is a bit trivial. Yeah. Not trivial, it's actually tricky. Yeah. So this is a problem that I gave you information about derivatives, right? It says there's something like this, right? Now I close this one. I don't need this one either. Well, this one is that f prime is minus k f. And my question is, what is f? Right? So I gave you information about derivative, and I asked you to find f. And this one is actually easy problem, but this kind of problem is called differential equation. This is very easy type of differentiation. This is called, actually this is called ordinary differential equation. This is called ordinary differential equation. And this is called ordinary differential, ODE, ordinary differential equation. And it is the easiest form of ODE. Well, I already gave a hint such that EX, right? EX thing. If we know, if we take derivative of EX, then it is EX, right? This is the convenient property of EX, right? Now we have minus K over here. Well, then we put A, let me put A over here. Then A comes here, right? Because of a chain rule, right? The chain rule, because we have to take a look at this part, AX part A. Now we have minus K, so, well, minus K, so instead of A, right? So we have minus K over here, then naturally we may need minus K over here, right? So F is E minus Ka. But actually, if you want a more general solution, even if you multiply constant over here, it doesn't change the solution, right? So actually, the answer for this one is EA minus KX, right? So this is the solution. Well, many of you miss this part, but it is not a big deal. But anyway, if you multiply constantly, it shouldn't affect the differentiation, right? Check it, right? If we take derivative one, then A is same over there. So, right? It is like this one. Yeah? In high school, you know, this one is like T, right? Then the question is, well, then Fx is like a Tx plus some constant, right? Yeah, something like this one, right? You have T, then you want to integrate it, then Tx, and it shouldn't affect the differential, so we will see. Likewise, we need some sort of a free parameter over here. Yeah? Well, this and this are the same thing. Free parameter. And if we give further information, then you can find this one A. But at this point, well, this is the general solution of this problem. Yeah. What is your question? Yes. You have a question, right? Now you understand it. Okay, good. Very good. So this is the called you can solve this on the educated guess, right? You learned, you are educated about this part. So using this educated guess, you are finding this solution. It's one way of finding solution, using educated guess. Basically, you are guessing upon what you learned last class. So educated guess. Actually, if you don't like, it is like, it is something like drawing some rabbit out of the hat, right? It looks like putting out a rabbit out of a hat, like a magician. So some of you may not like this educated guess, maybe not. Yeah, it just pumps out, right, from your guess. Some people don't like it. They don't like putting out a rabbit from a hat. They don't like that kind of approach. Well, if you don't like it, we can be more rigorous. No? One idea is divide each side with f. Then if we divide each side with f, then it becomes minus k, right? Now it becomes very similar to what we learned last week, right? And then this one, well, this one is, it is directly related to today's quiz. This one is basically log f differentiation, isn't it? Right? It is quiz number 3. Right? Quiz number 3. Because this one, right? We know if we take derivative of log f, it becomes f prime over f, because the chain rule is 1 over f and f prime, right? Because this one. Well, now it is easy. In order, it is like f prime x equal k, something like that. You already learned high school. In order to solve this one, you can do the integration each side, right? Integration each side, right? And we now it is exactly the same high school. Integration each side. Basically prime minus k, integrate each side. Then, well, it is differentiation. So if we integrate it, it becomes log fx, right? And if we integrate, it becomes minus kx plus some c, right? Isn't it? Yeah. It is exactly the same to high school math, right? So from here, you go here, and from here, you come here, right? Well, now we want what is fx. So, well, we can take exponential of each side. Log function is inverse function of exponential function. So, well, inverse function of log function is exponential function. So, if we take e each side, then it is inverse function. So f comes out, and e each side, then e fx equals e to the minus kx plus c. Well, and e to the power of c is just we write down a, so a e to the power of minus kx. So it is a way not using educated guess, step by step. But since you have you know what is the property of exponential function, you don't have to use this one. You can go directly to the solution. But this technique is also very useful technique. It is called the separation of variable. You separate all the x thing left hand side, all the non-x thing right hand side, put together and integrate done. It is called the separation of variable. Yeah, ordinary differential equations, and then solving it is called the separation of variables. Yeah, in math, separation of variables. Separation of variable, integrate, you are done. Kind of, yeah, very easy. It is fun, isn't it? 재미없어요? 네. Which one? You mean this part? This one? This one? From here to here? Okay. Good. Yeah, good question. Well, it is exponential function, so it is simply EC multiplied by E minus KX. Right? And then I call simply this one A. Of course, A should be greater than 0, right? Yeah, actually, it is for a complete solution, we need this one. A should be greater than 0. Any other question? Is it okay? 경제 수학 시간에 이런 거 안 배웠어요? 예, 배웠죠. 경제 수학 시간. 아, 뒤에 나왔어요? 네. 아, D가 나와서. 뭐, 알겠습니다. 아, 예. 여기서는 꼭 A뿔을 받기 바랍니다. 예, 재수강에도 A뿔 받을 수 있나요? 아, 재수강하면 A뿔 받을 수 있나요? 아, 그렇구나. 아, 오은이 한 번, 찬스는 한 번뿐이네. 그렇지, 다시 듣는데 A뿔 또 받을 수 있으면 불리하잖아. 아, 다른 학생들이 불리하니까. Anyway, yeah. So, this is the end of our fun quiz. Again, we will have this kind of thing every week. So, for the next class, so our next class would be beside the midterm exam. Our next class would be 23rd, and for 23rd, you have to take class. You have to watch. For the 23rd quiz, you have to watch this video, and then you have to study what we learned today. In addition to that, there is a midterm exam again. September 20th, we have first midterm exam. Again, you can bring one sheet handwritten note. Then, first, this is the scope of the exam is what we have class topics, which means this and this. Actually, I put a lot of. Yeah, our class topics. Well, if you go to Wikipedia, there are many complicated things. You don't have to study them. If you are of course, if you are interested, you can study them. But at least they are not in the exam. I'll make exam questions only out of the content that you learn. Don't worry about it. And then in addition to that, the class topic and then these two link in Khan Academy or linear algebra. So if you already know linear algebra, there are about 10 videos, and then second one, there are another vector and spaces. It is interesting geometry about there are some more, but don't worry about it. Each content is not that long, right? They are, for example, they are how many minutes? Each one is only 15 minutes.
2 videos ago, we asked ourselves if we could find the basis for the column space of A.
Something like this. And in addition to that, each one is, although it looks a lot, each link video is 10 or 15 minutes. In addition to that, you have long holiday. So you can study over the holiday. When your mommy and daddy want you to help them to prepare the party food and something like that, you have a nice excuse. Mommy and daddy, I have an exam, so let me study. Right? Okay, any question about midterm exam? Okay. Yes. Oh yes, that's another good question. Yes, about course web page. You can go to Hanyang portal. Course web page. Another one is you can type my name into Google. My name is Hyunggu-gang. You can type my name, and there is my web page. In my web page, you go to teaching, and then teaching there is a 2016 for mathematics for economics. You can click this one, and you will reach here. Easy. Yeah. You can just type my name in the Google. Yeah. And then we learned a lot of. By the way, next class, please bring laptop. Do you have a laptop? Notebook computer, laptop computer. You have, raise your hand if you don't have a laptop computer. Well, you can share a laptop. We have only 2 students who don't have laptop, so you can share computer with other students. So, next class, please bring laptop. We will use Excel to do some fun matrix algebra. We will do the practice. In Excel, you can do the matrix algebra. You can get inverse matrix and determinants and those things. Very fun. Okay. And then about chain rule, yeah. About differentiation rule and chain rule. Right? I assumed you know differentiation, but there are a lot of formula about differentiation. So when you have time, you can go to links, right? One nice property of differentiation is differentiation linear. Linear, it means that you can put differentiation inside of the function. This is linear, so it is a f bx. You can put this inside of it. So it is a f prime plus b g prime. It is called linear. Well, it is linear, so it is constant. Constant can go in front of it. It is a proper linear function. So differentiation linear, very important. And then product rule. Product rule is, you know this one. When h is fg, h prime is f prime g plus f plus g prime. It is high school math. Yeah. And then another important chain rule. Yeah? Chain rule. We keep talking about the chain rule. Right? Chain rule. When h is fgx, then h prime is f prime g prime. Right? It is chain rule. If we use Leibniz notation, then dh dx is like df dg dg dx. And then if we relax the interpretation of this one, then we often write this. And sometimes under some conditions, you can even cancel out these two. Sometimes. Under some conditions, we can even cancel out this and this one. Like algebra, right? Algebra. Sometimes it's possible. And then inverse function. Yeah, inverse function. When gf is f, fg is y, then g prime f prime g, something like this. Again, in Leibniz notation, dx dy is like arithmetic, right? Interesting property. Anyway, inverse function is special case of chain rule. So even if you don't remember this one, you can derive this one using chain rule. Doesn't matter. And then if you remember, we use basically this one to derive the differentiation of log x is 1 over x. We use this one. And the power law, you learn this one. Fx is xn, it is n xn minus 1. Right? When hx is 1 over f, well, it is also another chain rule. It is a chain rule. But it is also called, you are basically applying chain rule, but it is also called reciprocal rule. So h prime x f prime and fx square divided fx square and minus. Okay? Leibniz notation, it is again basically chain rule, right? Quotient rule, right? 1 over g, again, you can regard 1 over g as another function, then you can derive it. But anyway, f over g prime is f prime g minus g prime fm divided d square. And generalized power rule. It is, this is something you didn't learn in high school, I guess. Yeah. And it is another application of chain rule, but fg, and then it is differentiating f to the power of g, fx to the power of gx and divided with x, right? Then basically f gx g log f, you write this one, and then this comes outside, so you can derive it, right? It generalized power rule, right? So from here to here, you can go this one, right? You know, when there is something like this, you can change the location of this and this. Right? And it is a slight application of high school math. So we are to the power of g and prime. Wow, it looks difficult, but nothing to worry about. Well, we can do. First, we can do exponential function. Let's write down just e. E and the log. Well, e log together, they are same thing, right? And this is inverse function of this one, so we can put this one f power of g, right? right? And they are same because log is inverse function of e, so function inverse, then we have exactly the same thing. So this one should be same to this one, right? But then, wow, it is log function. So log to the power, so g can come is outside. Right? So it is the e and g log f, right? And we take derivative of this one. Well, now it becomes suddenly easy, right? It is now our convenient exponential function, right? Exponential function, so you can regard it to one big function. So take derivative one. So, well, first nothing changes, then you can only differentiate this one. Then now you can use chain rule, right? So wow, it is convenient thing. It is because exponential function. It is g, l, and f. Prime and exactly same thing, but this one is basically this one same fg, right? Exponential function, so this is basically same fg, right? That's why we have fg over here. It is the same fg, right? This thing and this thing is basically same. So, but then it is again easy. It is the g prime, so it is g prime l and f plus g and l and f prime and fg, and then l and f prime is, of course, it is the g prime l and f plus now g f prime, right? L and f prime is f prime over f, so fg. Well, it is now done, though they are same. Right, every slightly different for them. So yeah, it looks intimidating, but you know that's why we love exponential functions, right? Make our life easy. Right? 예, 뭐 질문 있어요? 예. 오케이. 야, 우리말로 해도 돼요. 어디 이거 이거 봐봐 L and F prime. So yeah, good question. So let's use yellow orange color. No. So basically we have this one and this one, right? We learned that L and Fx prime is Fx. Yeah, right. So what we just use is L and Fx prime is simply again chain rule. First is log function, so 1 over Fx, and then chain rule we have to add F prime, so we have basically F prime. The generalized power rule, but you don't, wow, it is horrible to memorize this one, right? Please don't memorize this one, it's too horrible. You just memorize the process. It is repeated application of chain rule. Yeah. Yes, that's another good question. Okay, so it is a big exponential function, right? It is a big EHX or something like this, right? So if we take derivative of EHX, then we know exactly the same thing, and the H prime X, right? So H prime X thing is like this one, and then we have exactly the same thing, but this big thing is from the beginning. This one is same to this one, and this one is just in front of it. So this big thing is basically same to FG. 무슨 말인지 알겠어요? 괜찮아. 익스포넨셜 펑션이니까 미분하면 이게 이렇게 되는데 이게 그대로 앞에 와서 프라임이 되는데 이건 그대로 남아 있는데 이건 애당초 처음에 똑같은 걸 하기 이렇게 익스포넨셜 로그 함수 역함수 한번 해준 거잖아요. 그래서 처음 거랑 똑같은 거지. 그래서 이렇게 쓴 겁니다. So they are same. So this is the key trick. Actually, the most important part is this one. We change fx to this form. Exponential, inverse of exponential, and the same one. This is a key part. From this, everything is just mechanical. This is the only part you need brain, basically. Differentiation, then it becomes in front of it, and the same. Same thing is from the beginning. It is function, inverse function. So you same previous one. Yes. So this is the most. Yeah. Another question. Yeah. Because we need this part. We have this part because we have this part. Well, from here to here directly, well, this is too difficult. So your question is basically, from here to here, we can go directly, but why need this intermediate step? Because otherwise we cannot solve this one. All right. 예, 그러니까 바로 여기로 갈 수 있는데, 여기서 이렇게 올 수 있는데, 여기는 프라임이 있고 여기는 프라임이 없죠. 바로 올 수 있는데, 여기서 여기까지 바로 오려면 y, 궁금하잖아. 그러니까 먼저 이렇게 익스포넨셜 로그에서 제자리를 만들어준 다음에 익스포넨셜 펑션 우리가 잘 알잖아. 익스포넨셜 펑션은 미분해도 자기 자신이 된다는 좋은 성질을 이용해서 이렇게 한다는 거죠. 그래서 일부러 그렇게 하는 거죠. So we go from here to we go from there to here directly. It is too difficult. So we are using the beautiful property of exponential function. We know at least that taking the differentiation of exponential function becomes exactly the same thing itself. So we are using that property. That it is the called generalized power rule, very fun. But again, it's repeated application of chain rule. Yeah? Chain rule. And then derivative of exponential. Well, this is what we learned today. It is it is the. Yeah, this is something we know. It is something. It is another one. Yeah, c to the power of ax. Now c is constant power of. Of course, you can use this the generalized power rule, right? F is just constant over here. Generalized power rule, right? Yeah. But again, the solution is that when you do something like this one, I recommend you to go to this part first. Then it's much easier. Right? Okay. So c to the power of ax. Well, it sounds difficult. Okay. You can use exponential function again. Well, then it is e log ax. Right? E log ax, right? No. E log c ax. We need the third floor, right? C x, right? Prime. Well, again, it can come outside. And then e ax log c prime. Well, then we are done. Basically, we have the same thing. So we have c ax, same thing. And then we have to take derivative only this part. Take derivative of x, then a log c. Done, right? So from here to here, and put ax outside. Yeah. Then derivative e becomes itself, so we put same thing, this entire thing and this is the same, so we put same thing, right? And then take differential chain rule, differential with respect to x, so a log c. Right? So it is same to the generalized power rule. Right, we already learned this one. Well, this one is also, yeah, this one now, okay. Okay, so log natural log. Prime is 1 over x. We know this one. When there is a basis e, we know this one, right? 1 over x. We know this one. But the question is, what if log some c? Now base is not e anymore. Huh? Any idea how we can do this one? Now it is not e anymore. 예? 뭐 어떤 아이디어? 누가 뭐라고 했는데? 강윤지 학생이 뭐? Yes, exactly. Great idea. Yeah? So log, we can decompose log. Another beautiful property of log. If it's log x, log c prime. Well, this is constant. We can put this on ice out. 1 over x. So it is 1 over x and log c. Done. Right? So we have this one. So no problem. Right? When we have not e basis, not we, no problem. 그냥 뭐 재미없어요? 재밌잖아. 네. Well, this is another. Well, you can do this. X to the power of x. It looks stupid. Well, it is, again, you can use a generalized power. You can do that. Well, this is generalized power. Yeah. Wow, this looks extremely stupid. H1 to the power of F2 to the power of Fn. Wow, how to do it? Then we have summation of, wow. Of course, you can prove this one. Yeah. Iteratively. And logarithmic derivatives. We learn this one, ln fx. You know this one. And now derivatives of trigonometric function. Well, this needs further explanation. Well, it will not be on midterm exam. Don't worry about it. But actually, it doesn't hurt you to know this one. If you take derivative of sine function, it becomes cosine. Cosine is minus sine. Tangent function is, of course, sine over cosine, so you can derive it. So, yeah. Don't worry. If you know these two, you can derive all the others. Yeah, it is possible. Yeah. And this is intuitive. Sine x is increasing function, so if you take derivative, first part is like 1, and at the top it is 0, so it is a cosine function. But if you take cosine function, it slopes down, so it should be minus, so it is sine. You can prove this one with some more rigorously. It's possible to prove this one rigorously. I can explain to you later. Differentiation of trigonometric function. And the table hyperbolic function. Well, you forget about it. And the special function, gamma function, Riemann zeta function. Well, you don't need it at this point. Yeah, and then differential trigonometric function, yeah, sine, cosine, and the proof of this one, proof. Actually, there is even proof, right? There is proof. It is a geometric proof. There are other ways to prove that sine x becomes cosine x. So, if you are interested in, you can look at the proof. Yeah, there are many different versions of the proof. From chain rule, this one is actually easy. Cosine x is cosine, so, well, this is easy one. Yeah, this is easy. Yeah, so, yeah, basically we are using chain rule. So cosine theta is same to sine pi over 2 minus theta, sine theta cosine pi over 2 minus theta, and then we use this chain rule, so like this one. Yeah. This is the easiest way to prove that. Yeah, this is chain rule. Fg prime prime prime, so yeah, cosine is minus sine theta, right? This part is doable, not difficult. Although it is not on the midterm exam, but still is doable.